All right, so we kind of got cut off here, but how do we use the valence electrons to determine the charge of an atom? Well, the goal here is that we want 8 valence electrons. And again, as a reminder, that is also known as our octet rule. We want a full octet. Okay, so the first rule, elements that have 3 valence electrons or less will lose their electrons. Okay, so it will become a cation. Elements that have 5 valence electrons or more, so that's 6 valence electrons and 7 valence electrons, they will gain electrons. Okay, elements that have 4 valence electrons, they could gain 4 or lose. So they can flip-flop. They can be a cation or an anion. All right, so why don't you guys pause the video to quickly catch up, because I am going to erase everything. Okay, and then the fourth thing is that if an atom already has 8 valence electrons, we don't need to add or subtract anything. So no electrons will be added or removed. Okay, so again, there are 4 rules to that. And in summary, I would do less than 3 valence electrons equals lose. Greater than 5 valence electrons equals gain. 4 valence electrons equals lose or gain. And if you have 8 valence electrons, nothing. All right, so how do we know the charge of a polyatomic ion? Well, I wish I had it pulled up now that I think about it. You should have received a sheet. Oh, I wish I had pulled this up. It's okay. It's worth it. This sheet right here. How do you know the charge? Well, this is your polyatomic handout. This is actually what you will be given on tests. So if you see HCO3 minus, or HCO3, you know that it has a charge of -1, right? A -1 charge. So what do we have to do to find the polyatomic? Look at the chart. Easy, right? Take a moment to catch up because I'm going to be scrolling up. I'm tall. It's erasing. All right, so moving on. Oh, that never works. So there are many types of bonds. Today we're going to be specifically focused on ionic bonds. Okay? Ionic bonds form when electrons are transferred between atoms. What does that mean to transfer? That means an electron is given completely, like a gift, from one atom to another. So they occur between metals and nonmetals, or between metals and polyatomics. Remember, polyatomics, those are on your sheet. Okay? So just as a reminder, how do we know if something is a metal or a nonmetal? Well, if you look at your periodic table, let me go ahead and just kind of erase this little loop here. We know that the stair-step line is right here. Okay, so anything to the left of the stair-step line is going to be metal. And anything to the right of the stair-step line is going to be a non-metal. Now you know that we have like these weird like metalloids that are all along the stair-step line, but I don't want you to really worry about those right now. Today it's all about non-metals and metals. And that is what occurs in an ionic bond. It is a bond between a metal and a non-metal, or a metal and a polyatomic. So I'm going to go ahead and add that little note to our notes that metals, they are right, or sorry, that is typo. They are left of the stair-step line. Whereas non-metals, they are right of the stair-step line. All right, so pause the video, make sure you're caught up. Go ahead and erase. All right, so finally, you and your group members are going to fill out this table. You don't really need to know a lot about ionic compounds to fill out this table. So if we look at this, the compound that we're going to start looking at is sodium fluoride. Sodium and fluoride, or fluorine. So the metal in this case is sodium. And I know that it's the metal, or this is a metal, because if we look at our periodic table, sodium is all the way to the left of the periodic table. So that's going to be the metal. And we also know that it has one valence electron. Remember, you can do this using one of two ways. You could either write out the electron configuration, or you could look at your periodic table with our new labels and see that sodium is in the first group on the periodic table. And if it's in the first group on the periodic table, it has one valence electron. Okay, so fluorine I know is my nonmetal. Whoops, wrong color. I know it's my nonmetal because if I look at the periodic table, it is, whoa, I got a lot of writing here. Oops. It is to the right of the stair-step line. I also know the number of valence electrons because it's in my group 7 valence electrons. So again, you could either do the electron configuration, which we should be pretty familiar with, or you could check the group number on the periodic table. The last step here is, in addition to figuring out our number of valence electrons, is figuring out the charge. Remember our rules from above? Well, if you have less than 3 valence electrons, that means you're going to lose those electrons. We have 1 valence electron, so that means we are going to lose our electron. If we lose 1 electron, we become more positive. For fluorine here, we have more than 5 electrons. And so we want to have 8, or a full shell. So we are going to gain 1 electron. If you gain 1 electron, you become more negative. So this is how we do the total charge. We like to create like a T-chart, and I like to write down my elements that I'm using, or my polyatomics if we look farther down. So Na and F for fluorine. Every single atom of fluorine, or sorry, of sodium has a +1 charge. So I'm going to go ahead and pretend that I have only 1 fluorine, or 1 sodium +1. And every single fluorine has a -1